So all we have to do is take our total known VAs and divide it by our service size. And that's going to give us our load in amps. And in this case, it's 96.35. We would round down to 96. Now we check for demand factors. Because this load calculation was already performed, there are no more demand factors to do. They were done along the way, right? We would have performed our range demand factor, our dryer demand factor, and then now we have this total lump sum of 23,123. So all we have to do is divide by 240, and there are no demand factors. Now that we have our known load, we head to table 240.6a, and we choose the next size up. And in this case is going to be a 100. Great job. What size main breaker would you select for a home with a total calculated load of 47,000 VAs on a 120 240 volt system? Step 1, find our total connected load. In this case, they've done all the math for us, and 47,000 are our total VAs. All we have to do is divide that by the system voltage. And in this case, it equals 195.83, and we would round down. Now we check for demand factors. And in this case, there are no demand factors because they were already performed to get us that 47,000 value. Now we head to table 240.6a and choose our next standard size. And in this case, it ends up being a 200 amp breaker. Great job. What size main breaker would you select for a home with a total calculated load of 38,000 VAs on a 120 240 volt system? Step 1, find our total connected load. They've already done the math for us, so all we have to do is divide by the system voltage. And in this case, it equals 158. Now we check for demand factors. And like we said before, there are no more demand factors on this calculation. We head over to table 240.6a, and we choose the next standard size breaker. And in this case, it's 175 amps. What size main breaker would you select for a business with a total calculated load of 95,000 VAs on a 140 240 volt system? Step 1, find our total connected load. They've already performed the load calculation for us, so all we have to do is divide by the system voltage. And we end up with 395.83, and we would round up to 396. Now we check for demand factors. And whether it's a home or a business, all the demand factors were already performed to get that original 95,000 number. So there are no more demand factors. Now we head to table 240.6a and we choose the next standard size breaker. And this would be a 400 amp breaker. This would also be a 400 amp service. Let's get to it. Now let's do that exact same calculation but on a three-phase system and show you the beauty of three-phase. What size main breaker would you select for a business with a total calculated load of 95,000 VAs on a 120 208 three-phase system? Step 1, find our total connected load. Well, they've already given us our total VAs, so all we have to do is divide. But with three-phase, there's one extra step. Because of the geometric nature of three-phase, we have to take that 208 and multiply it by the square root of 3. The square root of 3 just so happens to be 1.732. Once we work that math out, we end up with 360.256. And it seems like a lot of work on the front end, but you'll find out that you'll trade this little bit of math for what this is getting ready to provide for us. Now we can take and do our math, and after we divide it out, we end up with 263, and of course we would round up in this case. There are no more demand factors, so we head to table 240.6a and choose the next standard size. And this is where the beauty happens. We're going to now put this on a 300 amp breaker instead of, like in the previous question, it would be on a 400 amp, meaning that we'd have to have larger wire in the previous question, which may lead us to have larger pipe, which we may end up with a larger cost of overall project. The beauty of three-phase is the numbers come down. So this one's on a 300 amp service, which means we can put it on smaller wire, which might mean we can put it in smaller pipe, which might end up